Everybody, today is Tuesday, November 16th. We're going to finish up with our lesson 2.3 in energy's role in forming rocks. So this video is for students who were not in class today, and I'm not going to have you guys work on anything in Amplify. Really what the purpose of this video is just to make sure that you understand what we talked about in class that day and that you are responsible for the information. And when you come back to class, I'll catch you up and let you know what activities I'm going to let you guys just excuse and what activities I'm going to ask you to do. Okay. So yesterday, if you remember, we modeled weathering in order to break sedimentary and igneous rocks into smaller pieces. And of course, those pieces are called sediment. Once we shook those containers, we were able to break those pieces of candy into different smaller pieces. So we knew that we could weather both igneous and sedimentary rock. So next, we're going to watch a video that models how magma can form. So we're going to pay close attention to how the whole candies, the igneous rocks, that's the whole candy, and the crushed candies, the sedimentary rock, transform. So I want you guys just to watch this video real quick. There's no sound to it, so I can talk to you while it is playing. So they've got the whole candies first. So this is going to be the igneous rock model. Remember, the hard candies are good models because hard candy is made when hot liquid, it cools and it hardens into a solid. And so what we're doing now is we're adding heat. And when you add heat, then it's going to go back into that liquid state. So this is melting igneous rock. And you can see by adding heat, then we're able to melt. And remember where that heat comes from. It comes from the Earth's interior, so near the core. So the same thing, we're going to put the sedimentary rock there. And the same thing happens when you add heat, it's going to melt. Okay. So this one's kind of a little bit prettier because of the different colors, but the same thing happens. It's going to be melted rock. All right. So what happened in the video, we kind of talked through that. Where did the energy to melt the hard candy came from? It came from the hot plate. Where does the energy to melt real rocks come from? That comes from Earth's interior. So just a quick kind of review of the difference between a model and the real thing. In the rock making process, take a look at this little timeline. The column on the left is the rock making process. So cooling internally, cooling externally, meaning inside the Earth's core or above Earth's surface, compacting, cementing, weathering, and melting. The model candy, it didn't take very long, right? The compaction and cementation, here it said it wasn't tested. We actually did test ours. And it took about actually a week for that to work. But in relative terms, this is really short compared to the real world time scale, where we're talking anywhere from days to months to millions of years. The next thing we did in class is we did a second reading of Devil's Tower, and I'm just going to jump to this really quickly. I had the kids just read the third paragraph to the end of the article, and this is where they were looking for information that describes weathering and melting. If you read Devil's Tower, you're going to understand that in the past there was this hill right here, and it actually went above this. And over time, this area here, the rock that was here, that's sedimentary. And this is actually, it's called a plug, and it's a volcanic plug. It got full of the magma, but it never erupted. So it just kind of cooled and hardened right there in place. Well, over time, weathering occurred, and the sedimentary rock that was up here weathered and broke down, and erosion, wind, water, rain, it moved all of that away. And it is talking about how Devil's Tower is getting smaller because weathering process is happening to this as well. So we've got three key concepts, and I do want you to know the key concepts. And so if you want to stop and write these down in your good notes, we've got three key concepts already, 1, 2, and 3. Key concept number 4 says sediment forms when any type of rock is weathered. Any type of rock is weathered. And this is a process driven by energy from the sun. So go ahead and pause the video and write down this key concept in your good notes in the key concept graphic organizer. Okay, key concept number 5. Magma forms when any type of rock is melted, a process driven by energy from Earth's interior. Go ahead and pause the video and write that one down. Okay, and the last key concept for today has to do with energy and matter. And it's key concept number 6. Matter gets transformed by energy, but the same matter is still present. So even though the igneous rock can go through weathering and become sedimentary rock, those individual pieces of sediment are still igneous rock until they go through the compaction and cementation. It's still that same matter that's still present. Okay, then we jump to lesson 2.4, and I just had the kids do the warm-up. You won't have to do that. We skipped all the other activities, and I came to the very last activity, activity 4, and that's reflecting on the claims. So if you remember, we had claim number 1 that talked about the sediment formed the Great Plains came from the rock of the Rocky Mountains. The Rocky Mountains were formed first, and then through weathering, that sediment created the Great Plains. Claim number 2 says the magma that formed the Rocky Mountains came from the rock of the Great Plains. So the rock of the Great Plains had formed, and then there was subduction at a convergent plate boundary. The Great Plains rock went down below, that plate went below the upper plate. That Great Plains rock melted, became magma, and then at some point in time, there was a cooling and hardening above the surface of the earth, and that's what created the Rocky Mountains. Okay, so we know what happens when different rock types are exposed to different energy sources. And I want, basically, we just kind of went through and talked in class, could claim number 1 be plausible? Yeah, it could, because we proved that any kind of rock could be sedimentary rock. And then we talked about, could claim number 2 be plausible? And the answer to that is, yeah, right now it could be, because we saw in that video today that any type of rock can melt and become magma. So the question that I asked the kids was, which one do you think is right? And we kind of talked about why they thought it was right, why they thought it was plausible. But the bottom line is we just don't have enough information yet. So we're going to end the lesson here. And tomorrow we're going to take the mid-unit assessment. And if you are at home, I will have you take that at home just to see where you're at. And then in chapter 3, we're going to get some more information to see if we can answer those claims maybe a little bit better. Okay? All right, you guys, that is it for today. Thanks for listening, and hopefully I see you tomorrow.